question 5. Now, is that recording? It is. Okay. So, question 5. It says, below are 4 statements about 3 non-empty sets. So it says they're not null sets. The sets are P, Q, and R, and they're in a universal set U. Put a tick in the correct box in each case to show whether each statement is always true, sometimes true, or never true. And note that P dash is the complement of the set P. Now, I've just noticed now, actually, as I was about to do the solutions, that this is actually about 3 sets. So that one shouldn't have been asked. So now look, if you got marks for it because you guessed the right answer, I'm not going to take them off you. But I'm not going to go through it because it's about 3 sets. Anyway, so these questions, these sometimes true, always true questions, they come up a lot. And they're really tricky. So I'm going to show you what I do because I feel like you kind of need to understand it. So the first one says, well, can anyone read the first one to me? Can anybody read that first statement to me?
Cardinal number of P union Q equals cardinal plus cardinal Q.
Right. So this is, all those little hashtags are the cardinal number. And you describe this correctly. It's the union. So I know, I'm assuming from looking at your test that what you guys were doing were just kind of guessing a little bit. I think the easiest way to do this is to make up fake sets. Right? So let's say P is, I don't know, 1, 2, 3, 4. And Q is 2, 4, 6, 8. Yeah? Totally made up. Draw my Venn diagram. What goes in the center?
4 and 2.
4 and 2. And then in P?
1 and 3.
And in Q only?
6 and 6.
Okay. So, the statement says that the union is equal to the cardinal number of P plus the cardinal number of Q. Right. So what in this case is the cardinal number of the union? 1, 2, 3, 4, 5, 6. That is the cardinal number of the union. Agreed?
Yeah.
Right. The cardinal number of P then?
2.
It is 1, 2, 3, 4. So it's everything inside the circle P. So it's 4. What's the cardinal number of Q?
4.
It's everything inside the Q circle, which is also 4. So the question said they wanted us to investigate that the cardinal number of the union, which is 6, is equal to the cardinal number of P plus the cardinal number of Q. So in this situation, are they equal?
Yeah. No.
Is 6 equal to 4 plus 4?
No.
No. So in that situation, they are not equal. The union had 6 elements, P had 4 elements, and Q had 4 elements. When you added P and Q, you got 8. And when you counted the union, you got 6. So they don't match. What is it that's thrown it off? Why don't they match? Finn?
They don't match because they're different sets.
Is there anything I could change that might make them match? That's my question, I think. The intersection. Okay, the intersection is what's causing the problem. Because you can see here that in P we counted 4 and 2. And in Q, we counted 4 and 2 again. So what if I had two sets that don't have an overlap? So what if P was 1, 2, 3, 4, and Q was, I don't know, 5, 6, 7, 8? Right, what if it was that? What goes in the intersection? Nothing. What goes in the rest of P? 1, 2, 3, 4. What goes in the rest of Q?
5, 6, 7.
Right. Now let's do it. So the cardinal number of the union is 8. What's the cardinal number of P?
4.
And what's the cardinal number of Q?
4.
So now do they work?
Yes.
Yes. So if there's an intersection, it doesn't work. But if there's no intersection, that looks like a 5, it does work. So it's sometimes true. Now, I said it in the feedback I gave you. This was a higher level question. Okay? It was a junior cert higher level question. I was trying to push you with this question to see what you would do, to see where you would go. So I know this when I'm showing you the solution. I'm trying to show you the level of sort of, I don't know, is it detail that you need to apply to a higher level question? Okay, so you'll be more prepared next time. Right, the second one. So P, actually, no. Someone read it for me. Go on. Sanjit, yeah.
P less Q or P but not Q
Yeah,
is equal to P intersection Q.
good. Yeah? Okay, so let's try it. I have this set here. So P less Q is equal to P, I've lost it, P intersection, sorry. P intersection Q. Now. Okay, so using the numbers here, or the set, what's P less Q?
Just P.
So here's P, yeah, and then take Q away,
2,
1 and 3. Was it a cardinal number or was it just, no. Okay, so that's 1 and 3. And what's P intersection Q?
4 and 2.
4 and 2. Are they equal?
No.
No. Okay, so then let's try the other set, the one where we didn't have an overlap. So what in this case is P less Q? Good. 1, 2, 3, 4. And what's P intersection Q?
5, 7. Oh wait, yeah. 2.
It's a null set. So in this situation, are they equal? No. So what's the answer? Never true. Okay? So this is what you need to do. You need to investigate it and see, can you figure out. It's like, it's tough. Yeah? Did I? Oh, thanks. Sorry. It is never true. Sorry. Yes. Did I? I'll have a look in a minute. Just like put a circle around it or something. Is that all right?
Yes.
Okay, can we try then the last one, which is technically the last one now? So P intersection Q complement is equal to P complement union Q complement. Right. So can I continue to use this data? Assume I can. So P intersection Q complement. Sorry, I'm just trying to get the video going. Okay, so P intersection Q complement is supposed to be equal to P complement union Q complement. Okay, So, what is P intersection Q complement? Erin, do you know?
1, 3, 6, 8.
Very good. So P intersection Q complement is everything outside of the intersection. So if I block the intersection, what's left? 1, 3, 6, 8. So that's what that one is. 1, 3, 6, 8. Now, the next one, we need to do these separately. So, can anyone tell me what P complement is? Everything outside of P. So, block P, 6 and 8. All right, and then Q complement. Oh, let me scroll back down. So Q complement is 1 and 3. So block Q, 1 and 3. And then if I union the two of them, yeah, 1, 3, 6, 8. So are they the same? Yep. So there's P intersection Q complement. And then down here, I did P complement, Q complement, and then I put them together, or I unioned them, and I got the same answer. Yeah? Do you want to try it with the other one? Excuse me, let's see if it works. May as well. So, what was the first one? P intersection Q complement. Equals? Everything outside the intersection. Yes. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's do P complement. 5, 6, 7, 8. And Q complement. 1, 2, 3, 4. And then union them. 1, 2, 3, 4, 5, 6, 7, 8. Is it true? Yes. So what box would we tick? Always true. All right, so that's what we were looking for. Sometimes true, never true, and always true. The last one was also always true. But like I said, it's a 3-set one, so I'm not going to do it. Marks for that are slightly changed, so just double check. Can everybody double check this? The marks are now 0, 5, 8, 10. I'm going to tell you now. So this one, you get 5 if you've 1 correct. 8 if you've 2 correct. And then obviously 10 if you have all 3 correct. That's if you now are turning from a 3 to a 5, just make a note, write down +2 or whatever, and I'm happy to change it when I'm done making the video. Yep. If you got all 3 correct. You got the 4th one correct. And did you get the other 3 wrong?
No, I got the other 3 correct.
Oh, well then leave it. It's just 10. It doesn't matter. Like if you got... No. Nina? So that's going to be a 5 now. Okay. So guys, if you have any... Leo, is it a question about marks? It might. Just write +2. It depends how close you are to the next percent. Okay, so guys, all I'm asking for this at this moment is to make a note that you are due an extra 2 marks, or maybe, Nina, if I made a mistake, an extra 5 marks. Just write it down with a big question mark, And I'm happy to give you any marks you deserve. Just let me finish the video, okay? So, this. In a table quiz, 100 questions were asked. Team M answered 72 questions correctly and Team N answered 38 questions correctly. Find with the aid of the Venn diagram the minimum number of questions answered correctly by both. So we're looking for minimum and both, which means we're looking for the smallest possible number we can put into the intersection. That's what we're looking for. That's both. So, what does 38 and 72 add up to? It is 110. So, how many were asked?
100.
Right. So, how many has to go into the intersection? Has to be 10.
How? How's 10?
Because if I put 72 here and 38 here, I have too many people in the set.
Then how do you know that you take a certain amount from each?
Because it has to be, at a minimum, it has to be 10.
You said 100 questions were
At an
asked.
absolute minimum, it has to be 10 because it's the only thing that will make sense.
But then how would you know what to take away from 72 and what to take away from
I take 10. Because it means, okay, guys, shh, listen.
But you don't take 10 from each. You
I take 10 from both. So if I put 10 here, how many questions did Team M answer in total correctly? How many questions in total did Team M answer correctly, Dean? In total. 72. 10 of those were also answered correctly by the other team. So how many did only Team M answer correctly? 62. Okay, I'm going to stop that and we'll pick it up tomorrow.